Consider problem 5.59. In this problem, what do we have? We have a 10-meter high open cylinder and the area of the cylinder is 0.1 meter square. Okay, first things first, let's draw a 10-meter high open cylinder. Oh, come on. Okay, that's weird. I just draw it the good old way. We have a 10-meter high cylinder and the area is 0.1 meter square. It contains 20 degrees Celsius water above and 2 kg of 20 degrees Celsius water below. 198.5 kg thin insulated floating piston. So let us draw the floating piston like this. This is the piston. And what does it say? That it is insulated. Insulated. And above you have 20 degrees Celsius water above, and below you have 2 kg 20 degrees Celsius, and the insulated piston weighs 198.5 kg. Okay, assume standard G and atmospheric pressure. So atmospheric pressure and G standard. Now heat is added to the water below the piston, so it expands, pushing the piston up, causing the water on the top to spill over the edge. Meaning initially there is water everywhere, like so, and inside you have water like this, 2 kg 20 degrees Celsius. What's going on is you are heating this, and so because of the expansion the piston is pushed upwards and water starts to spill. Okay, the process continues until the piston reaches the top of the cylinder. Find the final state of the water below the piston and the heat added during the process. Okay, this is the question in its entirety. Okay, so the first things first, what is going on? Let us try to draw a PV diagram. Okay, so initially the pressure is high, and finally what is going on? So when you are heating, the pressure inside is increasing, but at the same time what is happening? Because of the expansion, so obviously volume is going to increase, but at the same time what is going to happen? You are causing
Decreasing the pressure.
water is going to come out, so you expect the curve to be something like this. Okay, this was fully loaded by water, fully loaded with water, and finally the piston has reached, so over here you have no water. Okay, so now why is this information important? Why have they given 2 kg water 20 degrees Celsius and 20 kg water up? We don't know how much fraction it is. Okay, so on this small control volume, which is on this small control mass, what is the total weight acting on it? We don't know. Can we find it out? Of course we can.
Yes, sir.
So let us say that, okay, before we do that, let us see whether we know the final state or not. What do we know the final state? What is the
Yes,
final
sir.
pressure? So what is
Sir,
the
we know pressure and volume.
So
So what is the final
atmospheric
pressure?
pressure plus weight of that piston.
Very good. So final pressure will be P atmospheric plus mass of piston times G over the area of the cylinder. Okay. So we call this as P2. So let's just call it P2. So at point 1, so this is P2 and this is P1. So at P1, it will obviously be P2 plus rho g is the hydrostatic pressure due to water, which will be rho g times h. Okay, and it is given that the total height is 10 meter. Total height is 10 meter. This total height is 10 meter. But let's say that this height is h. Okay, so we don't know what h is at the moment. And inside we have 20 kg. So we have 2 kg water at 20 degrees Celsius. Any other information do we have?
So we can use a specific volume at 20 degrees centigrade to find H.
Yeah, but you have not been given the total volume. You have not
So
been
we
given.
are given the height and area of the base of the
Yes,
cylinder.
sir. So we
So
can
total
subtract it.
volume can be found.
But even if you know the total volume, what are you going to do with it?
So, so like we know the total volume and the volume of the 2 kg and 20 degrees Celsius, the initial. Then we can
Um,
get the final, like the remaining.
How do you know the volume of this?
So
So we are
from
given
tables.
two states. So we know
You have
pressure
to.
at that.
I'll tell you how to do it. You have to do an equilibrium. So first of all, you have to do a force balance on the piston. On the piston, you have to do the force balance. So for the piston, you have what? You have P1 over here. You have mg of the piston, and you have water over here. So with the help of this, you will know what? You will know P1. Okay, let us do it. Let me. Hmm, yeah, I think. No, is it? Is there anything else that
So
is there?
actually we have given that the 2 kg is only water. So X will be like minus 100. So at 2 at 20 degrees Celsius we can find out that volume because it's very density is around like water.
Yeah,
Like
it's not gonna vary. That is fine, but the piston is also very heavy. Hmm.
So yes, sir. For the pink colored volume, we know the pressure, we know the temperature.
Actually,
So we
yes, we are
can easily
compressing
find
water, so
volume.
it's gonna definitely remain water only. So fine. So the mass is given at 20 degrees Celsius. Approximate V1 will be 0.001, okay, meter cube per kg. So the initial volume will be what? This will be the mass over the specific. So it will be 2 over 0.001, right? So
yes, sir.
hmm,
No, sir. Formula was
no, this
written
is
wrong.
not
Sir, and also we need to consider the pressure of, I mean, we approximated, right? The volume as 0.001.
But
this is
sir,
approximate.
actually, there is no need of pressure right now because we can't able to find out pressure along with the volume.
No. First, we are evaluating the volume so that we can know what this height is. Okay, this volume is equal to the
So
area of the cylinder. What is the area of the cylinder? 0.1.
0.1.
times the height lower. If I call this as the height lower, so height lower is equal to 0.1 meter square, right? Yeah, 0.02 meter. So this is only 0.02 meter. So the height above is going to be equal to 10 meter minus 0.02. This is equal to 9.98 meter. Okay. So using
Yes.
this, we can precisely pinpoint what P1 is. So P1 will be P2, that is P0 plus this term plus rho G times 9.98. So let us first find out what P2 is. So P2 will be equal to P0, which is 101.325 kilopascal, plus mass of piston, which is 198. So this is kilopascal, 198.5 times G 9.81 divided by area of cylinder, which is 0.1, but this unit will be pascal. So we will multiply and divide by 10 to the power 3 to make it kilopascal. So what do we get? 101.3.
So 120.79.
120.
Yes, sir.
Okay, let me just put it in my calculator. Oops.
Yes, sir. 120.87.
120.8. What?
120.79.
Let's keep it 120.8 kilopascal. So this is one result that we have. This is the final pressure, 120.8 kilopascal. Okay, keep this in mind. So this over here is 120.8 kilopascal. Now, what is P1? It will be 120.8
Here, rho
plus.
G into 9.98 divided by 1000, no?
Yeah, so it will be rho G into 9.98 over 1000, because the 1000 is coming because we want to rate it as kilopascal, no other reason. So rho is approximately 1000. So this cancels out. So it is simply G plus 9.98. So we have 9.81 times 9.98 plus 120.8. So this is 218.7.
Yes, sir.
Okay, so we have this pressure as 218.7. And so what is this initial volume? V1. The initial volume will be, so we already know the total, actually the initial specific volume is 0.001. And what is the final specific volume? So the final specific volume, so final state, what is going on actually? The pressure is reducing. Okay, why is the pressure reducing? Because the piston is going up, the water is spilling, but the total mass inside is still constant. Okay, it means the mass is constant, that is 2 kilogram. Volume at final state will be how much?
So volume of cylinder 10
It will
1 meter
be
cube.
10 meter times 1 meter square, that is 1 meter cube. So the final state will have a specific volume of 1 over 2, that is 0.5 meter cube per kg. Okay, this is the final volume. And what is the final pressure? The final pressure is P2, which is 120.8 kilopascal. Okay, so fine, we have completely understood how the process looks in the PV diagram. Why did we even bother to find out what the PV diagram looks like? And the reason is, let us write down the first law for the water under the piston as control mass. So water under the piston as control mass, you can write down U2 minus U1 is equal to Q12 minus W12. And this essentially means U12 is U2 minus U1 plus W12. And this is mass times U2 minus U1 plus W12 is now going to be integral P D capital V going from V1 to V2. What is the area under this curve? What is the area under this curve? This is nothing but integral P. So if I were to replace this volume by not the specific volume but by the total volume, I would get integral P dV. But because the mass is constant, I can write this as mass times U2 minus U1 plus mass times integral small v1 to small v2 P d small v, where v is now the specific volume. So now this will be m u2 minus u1 plus m times. So what is the area under the trapezoid? What is the area under the trapezoid? P1 plus P2 by 2 times V2 minus V1, right? Hello?
Yes, sir.
Yes, sir.
So now we know what we know so far. You know what P1 is, you know what P2 is, you know what V2 is, V1 is. We now simply need to find out U1 and U2. We know what mass is, definitely we know what mass is. So state 1, 120.8 kilopascal and V1 was 0.001. So U1 will be very close to U of the liquid.
Yes, sir.
Specific internal energy of liquid. State 2 is 100 and no sorry what is it 218 point something kilopascal and V2 is 0.5. I do not know where this point is, we need to find it out. 218 point what was it 7. So we need to know what U2 is. So let me first do it using EES. So I have to share my entire screen. Okay, let me just get rid of the ammonia problem from before. U1 equal to int energy steam P equal to 120.8 V equal to 0.001. Actually, a better way would be x equal to 0. U2 would be int energy steam P equal to 218.7 V2 equal to 0.5. Just run this. Obviously, we have encountered an error. So we will use, oh, come on.
So V equal to,
Yeah, okay. That was a very, what you know, what you call as a gamer thing, as a noob mistake. So Q12 is mass, which is 2 times 1753.440 plus 2 into 120.8 plus 218.7 over 2 times V2 minus 0.5 minus 0.001. So this unit, this is very important. No? This is kilojoule per kg times kg, and this is kg times, so this is kilopascal, this is meter cube per kg. So because of this kilopascal, this kilojoule matches. Otherwise, you have to really take care about the unit. So what do we get over here?
2795.4.
2795.4 kilojoule.
Kilojoule.
What did the question ask? PPV. So P and V we already found out. Actually, we were able to find out P without really doing anything. P and V we could do it fairly easily. So V was dead easy. Why? Because V is just it goes all the way to the top. There is no mass loss of this pink water. P we were easily able to find out using the assumption that the process is quasi-equilibrium. So whatever the external pressure is also the internal pressure. Temperature, I don't know. I don't know what the temperature is, but we have already found out what the total heat transfer is. Let us find out what the temperature will be. So state 2 is 218.7 kilopascal and 0.5 meter cube per kg. So first things first that we will look at 218.7 kilopascal at 218.7 kPa, is V2 less than Vg or V2 greater than Vg? If V2 is less than Vg, then we are in the saturated dome. If V2 is greater than Vg, then it will mean we are in the superheated steam. Okay, but over here I'm not gonna do this. You have to go ahead and do this. Did I write kg? This should be kPa. I'm gonna simply wiggle my way out of this. I'm gonna write over here that T at 2 will be temperature. I will simply copy this string because these states are the same. And finally, I obtain a temperature of 123.1 degrees Celsius. And as a matter of fact, just for you guys, I will say x2 is equal to quality. I will paste this. I will press F2. Nothing has happened. Okay. X2 is 0.6132. What does that mean, guys?
It is under dome.
It is
It
Such
is
under.
in the dome.
So, which of these is true, this or this?
V2 is less than Vg.
So we can expect this to be true. Do you want me to show you whether this is true or not?
No, sir. It's simple from
So we
table.
can just
From
Yeah.
appendix B. Okay, so I'm gonna stop recording now because we have successfully solved yet another problem.